Hi, today we'll try to solve this problem from homework 1. Uh, we can see that here is two vector force F1 and F2 is given, and we were asked to find the x and y component for these forces. So the force F1 is at an angle of 30 degree from y-axis, and force F2 is at an angle of 45 degree from x-axis. So this is positive side of the x-axis, and this is the negative side. This is the positive side of y-axis, and this is negative side of y-axis. So now for the F1 force, if we draw a right angle triangle here, then we can say this is the hypotenuse, this is the opposite side, and this is the adjacent side. So from trigonometry we can say cos theta is equal to adjacent divided by hypotenuse. So for this case, cos 30 degree, hypotenuse is F1, and this adjacent side, this is the actual component of F1 in y direction. We may call it F1y. So F1y is equal to F1 cos 30 degree. So by the same method we can find components in x direction and components of F2 in x and y direction. But there is a shortcut. We can, even without drawing this triangle, we can say that this was the adjacent of if there was a triangle. So, and this side is parallel to this x-axis. So we can say this x-axis is the opposite side and this y-axis is the adjacent side. So if we need to take a component of F1 in y-axis, which is in adjacent side in this case, then that component will be the vector in an multiplication of cos theta. And if we were to take the component in the opposite side, then the component will be equal to the vector multiplied by sine theta. So we can write down this here. The original vector into cos theta. The original vector into sine theta. So for F1, first we take the component in y-axis, that is F1y, that is a adjacent component for this angle. So we can say that we have already written that F1y is equal to F1 into cos 30 degree, Similar way, f1x would be f1 into sine 30 degree. Why? Because x1 is the x is not the adjacent side, adjacent axis. X is the opposite axis from f1 in respect to this 30 degree angle. So if we use the value, we can write is as if the value of f1 is 400 Newton. So cos 30 degree and 400 into sine 30 degree. So now if we use our calculator to find the result, (400 into cos 30 degree is equal to 346.4 Newton, because the unit for F1 was Newton. And if we use the sine 30 degree, the other component, then we find 200 Newton. So thus we get the components of F1 and F2. Thus we get the components of F1. Now we'll find the components of F2. For F2, F1x, F2x. Now let's see here, let's look at here. The axis is the adjacent axis in this case, so, and at an angle of 45 degree. So we can say that F2x is, as it is adjacent axis, it will be the cos theta. So F2 multiplied by cos 45 degree, which is, the F2 is 250 and cos 45, which comes to, using calculator we can find this equals to 176.77 Newton, because the unit of 250 was Newton and the angle doesn't have, cos theta doesn't have an angle, it's a ratio, it doesn't have a unit. So now let's take the component of F2 in y-axis. See, now the component will be in this direction of y-axis, which is the negative side of y-axis. That's why y will be negative. The value of y will be negative. Then we can say that F2 multiplied by, this is the, for this 45 degree angle, this side is the opposite axis. That's why we can say it's a sine 45 degree. So putting the values and using calculator, we can find this equal to minus 176.77 newtons. So now we got all the x and y components for both F1 and F2 first. Now we need to put these components as a vector form if we want to. So we can write this f1 vector is equal to f1x, the value of f1x, that's the scalar, the magnitude, and we need to put the direction. We know that in x direction there is a unit vector, that is I cap, and in that's the y direction. In x direction there will be I cap, and in y direction there will be j cap. So we can write it as f1x I cap plus f1y j cap, or you may write just I and j. So putting the values that we have acquired, I can write as f1x is equal to 200, sorry, I plus 346.4 J, and the unit is Newton. Similar way, f2 vector is f2x I plus f2y j, so that would be equal to, we can round it up as 177, then 177 I plus minus minus 177 J Newton. This is the solution for this problem.